It's mid-March 2011. Today, we're going to show you more about how Cooperative Mineral Resources is demonstrating a new way to extract rich manganese located 300 to 400 feet below the Earth's surface. The goal is to demonstrate this new environmentally friendly way to recover the mineral to see if it makes sense to plan for commercial operation. This manganese project is unique and has the potential to create a real financial benefit to the City of Emily, the State of Minnesota, as well as the people who live and work in our community. Manganese is mainly used in the steelmaking industry, but is also being looked at as an element to help extend battery life. Manganese has been selected by several automobile manufacturers as a mineral of choice for improving electric car batteries. This is an important project that has taken us years to plan and prepare for. Today, we will join Shar Kinzer, Public Relations Manager for the project, at the site just north of Emily. Shar will show us more about what is happening and how the project works.
Hi, I'm Shar Kinzer, Public Relations Manager for Crowing Power and Cooperative Mineral Resources. We're here at the manganese site about 1 mile north of Emily. Beneath us, there's estimated to be 1 to 3 billion pounds of the richest manganese deposit known in North America. Cooperative Mineral Resources bought this site to ensure that all of the benefits from this project would stay within the community. We spent about 2 years looking at the best way to extract the manganese from the ground, from the 300 to 400 feet below the surface, in an environmentally friendly way. Our plan uses only high-pressure water jets, using existing groundwater. We worked with the City of Emily, the state, and federal regulatory agencies in order to obtain permits for this demonstration project. Our challenge and our commitment is to respect the environment and to make sure that this project helps the community and everyone in our region. Now let's go down to the borehole where this process begins. The rich manganese is in a mixture of iron, sand, and silica. To get at the deposit, we've drilled one 14-inch well and are using this well rig from Lampert Drilling in Emily. As we lowered a borehole extraction tool inside the well, and that turns slowly with the well rig. And as it turns, it shoots water jets out 30 feet on each side, and it loosens up the manganese and the iron and the silica and draws it back up the well. Using existing groundwater only, these high-pressure water jets are able to break up the rich manganese and draw it up to the surface. Again, we're about 200 to 400 feet below the Earth's surface, where the richest deposit is located. The wet mixture that's brought up the well first goes into this building called the Grizzly Building.
Inside the building, larger pieces of ore are sorted and removed and dropped into a holding bin. Smaller fine material is sent in a slurry mixture of water, manganese, iron, and silica to a processing building through these pipes. Inside the process building, the slurry mixture goes through a number of processes, equipment that was carefully designed to separate the material and extract 80 to 90% of the water. The water is carefully filtered and returned as recycled groundwater back to the borehole where we started. The conveyor belts drop the finished material inside this building that is covered and protected from the weather. The ore is a wet mixture of manganese, iron, and silica that will be processed to separate each of the three elements. We make sure the ore material is still wet to reduce any dust. Moisture levels are carefully monitored, and on average the moisture content has been 20%. A front-end loader carefully loads the product into side dump trucks. The trucks are special because all the seams and seals are welded to make sure nothing can leak or spill out of the truck when it is on its way to the processing center. The trucks are then tightly covered by a spring-loaded tool that draws a tarp over the material in preparation for transport. Before every truck leaves the site, tires are washed at this tire wash station to ensure no material is tracked onto roadways. This particular truckload is headed to the University of Minnesota Mineral Research Lab in Coleraine, where Dave Hendrickson, head of the lab, is working to determine the best methods of processing the manganese for future use. Some of the shipments are also being transported to Midland Research Center in Nashwauk, Minnesota. The demonstration project is being done to help us learn important information that will help us determine the financial feasibility of extracting and processing manganese in this fashion. We are also taking this special step to show how the process will not harm the environment. In addition to taking ore from the site, we're also conducting tests of water from wells and area lakes, as well as measuring ground movement around the site. Thank you for taking the time to watch our video and learn more about Cooperative Mineral Resources' exciting new manganese extraction project in Emily, Minnesota.